Well, so let's go to questions then. Again, and let me see. It is Option Y on Mac or Alt Y on Windows. And there's a button hidden in the Zoom menu somewhere too. If anybody has questions for Mike.
Hopefully I didn't scare him off for all the numbers.
No, you didn't scare him off. But you know, I think we don't have a lot of questions. Oh, there's Will. I think typically we don't because you've come on several times, right? So folks have had them answered in the past.
Yes.
Will, go for it, sir. Oh, hang on just a second.
Muted.
Yeah. Hold on. There we go. I'll ask him to unmute, and I just checked it so people can unmute themselves.
Okay, yeah, I pressed a button, an error came up. So, yeah, hey, I was just looking at your device there. It's rather cool. I was wondering, you said make it lighter. So, have you thought about using composites?
Well, yes, I use this is the first of 5. I've been working on this thing for 5 years for Tom. Every year I would go down and present at the COFE conference until we got it running. It took me 5 years. Like I said, it's kind of a part-time hobby. First, the next session that I will present is on optimization of it. Eventually, it does work.
It does seem like that would be the way to go.
Yeah.
So, are you trying to make this for space? What is your actual goal for this project?
Well, this was just they're already in space. Boeing has them in space along with a lot of other aerospace companies. All your geosync satellites have 4 gyros on them for station keeping, same as the International Space Station. It has 4 big ones, 4-foot rotors.
Yeah, but I mean, what is the actual, I mean, obviously Tom, Tom seems, I read his book, so I think he has some, future goal.
Yeah.
And so I wonder what that goal is.
Yeah, he was very interested in inertial propulsion, and he couldn't twist my arm fast enough to build him a tabletop model.
So is he considering terrestrial use or space use?
I would say space for terrestrial, you got a few problems. They'll never make a rocket engine out of one because the weight of the vehicle, you can't blast off with it. But once you get it in space, the weight of the vehicle goes to 0. So whatever forces it generates, you have the test article I showed you, all bug eyes there. The weighs 1,500 pounds and it generates, let's say, 300 pounds of thrust. Well, that's not going to blast off the Earth. But once you get it in space, the 1,500 pounds goes away and you're left with 300 pounds of thrust.
Yeah, I've seen researchers experimenting with gyros to try to make counter forces for drones. Do you think that this might have some applications there?
They already have laser gyros on drones for stability.
Yeah, but yeah, that's for stability. But I've seen researchers use them to try and make, different, try to change the direction of the craft while it was going forward. So it'd be going forward and try to make the direction of change using some mass.
Yeah, gyroscopes work for that. The old German Hannibal flying saucer had 3 gyros at the bottom of it for flight controls.
Oh, I didn't know that. You have documents on that, or?
Well, I pitched that here. What was it? 1 or 2 pitches ago was on linear propulsion.
Okay, and thank you very much.
Okay, so let's go to Robert next.
Hi, Mike.
Yeah.
I'm just curious what the first prototype you built. Was that the financial constraints, or You just didn't have the tools to do like a software or a modeling type of optimization, and
Well,
then build the.
Well, the first
device.
cut, Tom just wanted me to get something going. So I got some aluminum plates and mounted the gyros on there just to see what what I got. And then from there, I started doing the optimization. I lightened the frame, changed the controllers. And we finally got it working for him, and he was very happy with it.
When was your first talk on this here on APEC? What date? Do you remember?
The date, I don't remember. The name of the pitch
Okay.
was History of Boeing CMG Work.
Okay.
Tim could probably tell you, or
You know,
Yeah.
I wouldn't even be able to look it up either. Mike, you've been on, I think 6 or 7 times now. So I would say probably the best thing
Okay.
to do is just go to the Alt Propulsion site and hit search and type in Mike Gamble, and
it's
All
on
right.
there somewhere, I'm sure.
Okay. What does CMG stand for? Just curious.
Controlled moment gyros.
Okay. All right. Thanks, Mike.
Yeah.
yeah. So okay, let's go to Harold next. Harold.
Thank you.
You're on.
Oh.
Hey, Mike, great
Oh.
presentation. Thank
There
you.
we go.
2 questions. Number 1 question, the design of the rotor. What kind of approach do you use? Do you have the design like the flywheel type with the mast at the rim, or is just a plain disc, flat disc, would you set up spinning? What
Well-
design do you use for the rotor?
Well, it'd be flywheel type. We bought the gyroscopes already built from this website that I just gave you.
Uh-huh.
I've been helping Mark. He's building some bigger ones. He'll probably, I don't know if he's on right now or not, but he's building some 3 and 4 inch ones. These are only 2 inch, so they're pretty small. So what I had to do was make the frame lighter and smaller too, because I needed bigger gyros. So you either make the gyros bigger or make the frame smaller until you get it to self-propulsion.
Oh, good. Thank you. My second question, what is the comparison in the performance of when it is spinning and the rotor versus the disc, the rotor being horizontal, perpendicular to the gravity vector? What is the difference in the performance of both of them?
Well, the gyros put out the same amount of thrust. It's just I had to go vertical, so because the load cell would only measure, in the gravity direction in the negative y-axis. Now, since then, I've put an accelerometer on there and got rid of the load cell, so I can measure the thrust in the horizontal axis.
What thrust to weight ratio are you aiming right now? Do you have right now with with what you have versus the weight of the unit,
Well,
the
right.
control?
We started off at 17 pounds. It's now down to 9 pounds, and it generates about 3.3 ounces of thrust.
Performance showing
The weight,
something.
the
Hey,
weight,
thank you. Patient,
weight to
keep
thrust
up the
ratio is
work.
very small for linear propulsion. That's what I said on the Boeing one there.
Okay.
The frame was 1,500 pounds and it generated 300 pounds of thrust. That's why you can't
Oh,
use
that's very
blast
good.
off.
Also awesome. Thank you, Mike.
Okay. And Harold, thank you, sir. So let me see. Any other questions for Mike?
I have a
Go.
question.
Go for it, ma'am.
Okay, the device that you just showed, all right, the gyroscope and the unit that it's connected to measuring it. Could this be built? And let's say all these scientists, their stuff is taken away, but when they're wherever their stuff is, it has a signal that it recognizes in space and time to give it a start code. So some of these machines just start on their own, like as we saw in your machine, how it just started, you know, on its own from whatever the resonance frequency from that particular, you know, people that work with their hands, they put their DNA on it, you know, it's not just machines, it's, you know, with the, like our energy gets deposited. So, you know, into these things, and it's a code, like, you know, mathematical code plus genetic code, they have to match, you know, to match up to create what the parallel is called of time, what time is, how do we find time and science together where, you know, they meet, because you're always going to have a shift, but you would have a, you know, a genetic line, generational line. That's the real, that's the real world. That would be the machine world. You understand? And whenever like it makes a parallel, that's existence. That's real time.
I'm afraid I don't understand what the question is.
What are you trying to describe?
What am I trying to describe?
Yeah, like in real terms. What are you after? What were you trying to prove? Are you have to be after some, you know, not
Well,
just
yeah,
mathematics.
the
What are you trying to prove?
Well,
the
he's
logic is to generate linear thrust using
The
rotor.
possibility of existence on a higher plane. How do you do that? You know.
I think
frequency
Lulu, I
everywhere.
think that might be a little beyond our
No, that's your gyroscope's rotation rate. It's going to have a resonance factor of, you know, an apex point that, you know, like all the frequencies are gonna, like, you know, settle on that plane. So, you know, just, you're talking, this isn't, you know, a place where it's closed. If you have a refraction, like a window to it, then, you know, it could be a reverse code for it to start. It could be just anywhere. It's just it's a, you know, a reflective, whatever that glass, or, you know, whatever that thickness of whatever it is in, it just, you know, do the opposite and it could start, like, you know, give it like an electron, like, or electron or whatever it is. It just depends on whatever you started with.
yeah.
You know? Yeah.
Well, let's yeah.
I love like, listen, I love your work. I understand it with all my heart. And so when I explain it back, it's like, I want confirmation. Like, am I right? Like, tell me I'm right. Because if I'm right, this would be like the coolest things, you know, like existence, like multi-dimensional existence. We could like travel to different places and, you know, like send our physical laws first before we send ourselves. So when we get there, you know, we're comfortable. Like, just, I mean, like multitudes of possibilities with this. Like, it's really cool. I really appreciate your work. You know, I'm sorry I always barge in, but, you know, that's just my.
You're doing great,
Moment.
Lulu. You're doing great.
Thank you, guys.
Oh, okay. So let's do this. I think we're all set. It's 3 o'clock now. Let me see if Mark Sokol. Robert, did you have a quick question or?
Yeah, I just want to, I missed the video. I guess I couldn't get it to run. Is there a way of
You want me to try and
you
fire
it
it up?
on?
Yeah. Try do the video one more time, and then after that, I'm
Okay,
going to go to
hang on
Mark
a minute. We'll
Sokol.
give it a shot.
Mark says not ready for lab update.
Okay, are you seeing it? Or what are you seeing, I guess would be the question.
Oh, you're not sharing your screen.
Oh, okay, hang on a minute. Wrong button. Oh, let's try share screen again. Okay. Oh, new screen. Let's try that. Are you seeing that?
Yeah. Yes. Yeah, I see it.
Okay, you want me to run it again?
Just one more time.
Okay.
So as the two rotate, they're causing a linear force up.
No, the force is down.
Okay. They're causing a downward force. Okay.
Mhm.
In addition to their own weight, obviously.
Yeah. Tim, can you clear that out? I can't get it cleared.
Oh, you want me to stop your screen share?
Yeah, yes.
Yes, sir. Hang on. So I'm going to remove the spotlight from Mike. Okay, and you know what? I should have done that. That may screw up our archive video. I should have removed that when we started Q&A. And then I'll stop your sharing. There we go.
Okay, there we go.
Okay, yeah. Sorry, I removed the spotlight. I'll lower the hand. And Mark said, let me go to Morgan. Morgan, go for it, sir.
Yeah, okay. Thanks for this presentation, Mike. I wanted to, so just building off this video that you just showed, can you describe to me really fast? So you have two gyroscopes pointing at each other, right? Which is the direction of rotation of each?
Same direction. And
like both right-handed or both left-handed?
Yeah, they're both.
Okay, both.
If you want to generate torque, you spin them in the opposite way. If you want to generate linear thrust, you spin them in the same direction.
Okay, and then so you have them both right-hand rotation, and then you're oscillating them up and down.
Yeah.
Are you is the rotation staying the same at each point?
Yeah.
As you're oscillating it down, the rotation is constant, right?
Yes. Well,
and
the gyros slow down just a little bit because you're extracting power from them on the power stroke.
I see. Okay, and then I see. So they rotate down, they slow down. Whenever they rotate back up, or does it stay constant rotational velocity, then they roll back up, and then they increase their velocity again?
Well, the motors keep turning as constant as they can, but on the downstroke, they lose a little bit of energy. But in the time it takes to go back to the reset stroke, they're already back up to speed. The motors, in the 600 milliseconds that it takes to reset, the motors have already pulled them back up to speed.
Okay, so then, okay, and then, so the angles that they go down, are you setting that, or this is part of, I don't know if this is part of your calculations, but the angles that they rotate down, are those selected for some reason?
Yes.
To like maximize the effect or something like this?
Was plus or minus 45, and then through my optimization, I get that down to about plus or minus 20.
Okay, and then so you are measuring I guess it's an increase in mass, right? Or which, I forget which direction is the thrust. Is it up or down?
Down.
Okay, so you're actually measuring an increase in mass or an increase in weight?
Well, it's thrust.
Sure, whatever, you know, if you subtract off, and then you don't see anything as they rotate back up. It's not like the mass of the thing is oscillating.
No.
Or it stays with a continuous thrust down.
It may be a little bit, but the noise charts that I showed you has a lot of background noise, so it's probably down in the mud. There's
okay.
A lot of noise there from vibration. So in theory, they should the gyros should speed up a little bit if you're going the opposite direction in theory, but the motor holds them as constant as it can. On the power stroke, you're extracting a lot of energy, and you're not doing that on the power stroke. But in theory, they should increase one way and decrease the other. If you watch Lathowitz, there was some discussion earlier about Lathowitz. As long as he's spinning or turning or processing the gyro, there's no weight on it. As soon as he stops procession, the weight appears immediately. So it's the same principle here.
I see. Okay. And so you measured thrust on this.
Horizontal.
You actually measured a thrust on this thing, and it wasn't oscillating. It wasn't like sinusoidal as it goes up and down. It was continuous in one direction.
Yes. It's noisy, but it's there.
And what was it? I forget. You had mentioned that there was like it's actually generating quite a bit of thrust, just not enough to make it levitate or something like this. What was the actual thrust that it got?
I get 2 ounces of thrust, but if I put a scale on it, it requires 3 to drag it across the ground.
Okay. Huh. Okay, that's cool, I guess. Yeah. Really? Are you? So what are you doing next with this thing? Are you building bigger ones, or what are you doing?
Well, I've optimized this one enough to get it to run. I'm hoping to get some of Mark's gyros here. He's making some 3 and 4 inch gyros, which will generate more power.
And oh, how fast are they spinning, by the way?
16,000 RPM.
Oh, wow. Okay. Wow. Cool.
88
thanks.
joules by calculation. That's
Yeah.
quite a bit of power.
Yeah. That's a lot faster than what I was thinking. That's really cool. You know, it's funny because that kind of, I don't want, I feel like I'm going to catch flack for this, but it does kind of have this, what is it? This gravito, it has, what is it? Gravito magnetic effect type thing. What, it's just pure gyroscopic stuff though, right? Nothing great. Like,
Yeah. Well, the last presentation I did was a comparison between mechanical force or thrust and electrical force or thrust. I'm of the opinion, being an electrical engineer, that anything that moves is an electromagnetic field, and you can generate the same force that you do with a gyroscope by spinning a magnetic field.
sure. Yeah. Okay. Yeah. So this is kind of some weird like flywheel type thing. You're converting the rotational energy into some sort of kinetic energy somehow.
Linear energy, yes.
Yeah.
You're basically, you're rectifying it same as you do with AC voltage. When you convert it to DC, you rectify it, or off-centered is what you're doing.
So this is, I guess, conservation momentum. You're converting, I guess, angular momentum to linear momentum.
Yep, exactly.
That's interesting. Okay, cool. really cool, I think. Yeah. Thank you.
You bet.
Yeah, and thank you, Morgan. Let me go to Will next. Will?
You're muted. There you go.
So I was looking at your video, because this time I can see the video more clearly. And I noticed that you were using 3 channels on your scope. And only the first channel had anything going across it. So I'm wondering, is your sampling rate too low on that older scope?
No, if you go slow speed on the scope to pick up the servo time, the pulses from the pulse counter on the gyros just smudges out because they're at very high speed.
Oh, okay, so this is an artifact of the
either have
gyros
to set the
themselves.
scope at high speed to pick up if you want the gyro information, which is the pulsing at 16,000 hertz or 16,000 RPM, which is about 260 hertz.
26 hertz.
And then if you go to the gyro slew rate, you're down to 700 milliseconds slew rate. And so the two are incompatible, so you have to take separate pictures off the scope.
Right. So in other words, you probably need a faster scope.
Well, no, you can't take the two
No.
pictures at the same time. You can speed the scope up to get the gyro data, but then you lose the frame or the force data. And if you slow the scope down for the force data, you're going to lose the gyro data.
Right. Oh, yeah. Okay.
One's down in milliseconds, and the other is at microseconds.
Yeah, I think the more modern scopes. I have a Keysight here, Infinivision,
Yeah.
and
if you look at the
I
picture,
can separate the channels.
yeah, well,
and up
this
to
one,
5 gigasamples.
yeah,
So,
well, this doesn't have it, but if you look at the scope, the purple line there is the force output, and the yellow line that's all fuzzed out is the gyros.
yeah. Okay. Anyway, thank you. I can see. I understand what you're saying. So thank you very much.
Okay.
Awesome. Awesome. Well, so I think we've got about 45 minutes left until Mark is ready to go. I think we're all out of questions. So why don't we do this? Everybody, I'm going to put this back on gallery view. Everyone, Mike Gamble, one more hand. Mike, thank you again for presenting, sir. Thank you so much.
No problem. Just holler when you want me back.
Yeah, of course. Of course. Well,